let me show you how to calculate molar mass. So I want to start with something simple like KCl. So in KCl, you have 1K and 1Cl. And so what you're going to do is go look at the periodic table and find the values of the molar mass for each individual element. So for K is 39.1 and for Cl is 35.45. So you're just going to pull out your calculator and add those things together. And you're going to get 74.55. So if you need the molar mass of KCl, that's what you're going to use. Now, if you have a subscript involved, that means that you have more than one atom of that particular kind present in the compound. So for example, NCl3. Now we'll get into why you have more than one atom in there later. But for now, let's just accept that it's happening. So your nitrogen is going to be 14.01. And then you're going to take that same 35.45 for Cl, but now you're going to multiply it by 3 because it has a subscript. So this is just like in math. Okay, this comes out here. Then you would multiply these together and sum. So I've gone ahead and done that addition, or sorry, that kind of pulled that out. But you don't have to do that. You can let your calculator do all the heavy lifting here. And so that would be 120.36 grams per mole. So this is the same idea, but I did want to show you that you can do the same process with more than one atom. So here's barium sulfate, BaSO4. So you're going to find the value for barium off the periodic table, which is going to be 137.33. Sulfur is 32.07. Oxygen is 16. Because that 4 is outside the, or next to the oxygen, you're going to multiply that by 4. Here's those terms, sum them together, and you're going to get 233.4. Now, the last thing I want to show you is that sometimes, so anytime we have, something here, and then we've got this other kind of group here. This group is called a polyatomic. Sometimes you need more than one polyatomic. Okay, so for example, if you have barium chlorate, so you need 2 chlorates to have a balanced neutral compound with barium. We'll again get more into that a little bit later. But if you're calculating the molar mass of that, this 2 is going to distribute into your parentheses, again, just like it would in math. So I thought it might be helpful here to show you kind of the number of atoms of each kind that you have. So you have 1 barium because it is not inside the parentheses, so it stays on its own. And then that 2 distributes to the chlorine. That's Cl, by the way, not Ci. So 2 chlorines, and then 2 times 3 is 6. So then that's 6 oxygens. And then your process becomes the same. So there's your barium, and then 2 times your chlorine, and then 6 times your oxygen. Sum them all together, and you get 304.23. So that's how you do molar mass.